Water is vital for all living things in the world, from microscopic organism to macroscopic organism. Water is crucial needs for our survival. Water is a special compound compared to other liquids. So, what's so special about water? Let's begin our journey.
Hi, my name is Manjahal and I'm from SPK 1013 Group A, and I want to present you the properties of water. And the properties of water include the cohesion and adhesion forces. So what is cohesion and what is adhesion? So cohesion is the attraction between two same molecule or substance which stick together and form a forces. And what is adhesion? Adhesion is the attraction between two different types of substance or molecule which bind together. There are so many types of experiments which can prove that the unique properties of water, which is adhesion and cohesion. Today I want to present you two experiments which can determine or to prove that the cohesion and adhesion forces in water. The first experiment I will present you is we need to prepare 2 cups and 1 string and some cellophane tape. Okay, so the first experiment we need to do is we need to use the cellophane tape, okay, which can stick the string in the water glasses, okay, and 2 sides of the string, just place it. Okay, you form like this. After that, I will pour some water into this cup and let's see what will happen. Okay, we will fill the water in the cup and then we just submerge the string in the water and both. Okay, just pour it as higher as you can. Okay, you see the water will follow the string and then flow into the other side of the cup. So now we can see that the second cup is filled with water from the first cup. Okay, this is because the cohesion and adhesion is occur. The cohesion is occur in the water. The water is cohesion, the attraction between two same type of molecule or substance, which is water, is pulling each other to move it. So, and another is the adhesion is occur between the water and the string or the roots. Okay, so the water will flow from the first cup to the second cup. It's because of cohesion and adhesion forces. Okay, now I want to present you the second experiment which is related to the cohesion and adhesion of water. So the apparatus we need to use is a coin and a cup of water and a dropper. Okay, so we just use a straw or a dropper. Because I don't have a dropper, so just use a straw. Just drop by drop. Drop it. Drop it. Okay, that's all from me. This is the experiment about cohesion and adhesion. Thank you.
Hi everyone, my name is Hu Xuewei and I am from SPK 1013 Group A. Today, I'm going to show you an experiment about solvent properties of water. To carry out the experiment, we need to prepare 3 glasses of water. Besides, we also need to prepare salts, baking soda, and oil. And we also need to prepare spoon. Well, now I'm going to carry out this experiment. First, we need to put the salt inside the glass that filled with water and then stir. After that, same method is used for baking soda and oil. Well, from the result of the experiment, we can notice that the salt is already dissolved in water. And for the baking soda, it's also dissolved in water. Well, for the oil, it does not dissolve in water. And we can notice that the oil floats on the water. Okay, why the salt and baking soda, they can dissolve in water, but the oil, it does not dissolve in water? Let me explain to you.
Salt can dissolve in water because it is ionic compound. Ionic compound is hydrophilic, which means water-loving. Hence, that's why the salt can dissolve in water. And when the salt react with the water molecule, hydrogen shell will be formed between them. And the interaction between them is ion-dipole interaction. Next, baking soda. Baking soda can dissolve in water because it is polar compound. Polar compound is hydrophilic, which means water-loving. So that's why the baking soda can dissolve in water. And when the baking soda react with the water molecule, hydrogen bond will be formed between them. And the interaction between them is dipole-dipole interaction. Next, oil. Oil does not dissolve in water because it is non-polar compound. Non-polar compound is hydrophobic, which means water-fearing. Hence, the oil does not dissolve in water and float on water. Therefore, there is no ion-dipole interaction or dipole-dipole interaction happens between the oil and the water molecules. So, in conclusion, we can conclude that when the water reacts with different solid, it will give different solvent properties.
Good evening. Okay, my name is Muhammad Syahmi bin Mazlan and I'm a holder of metric number, and today I will conduct an experiment about thermal properties of water. Okay, to conduct this experiment, we need to prepare some water, leaves, a tape, a candle, and if necessary, a wooden box. We're gonna make this leaf into this. How? We just apply the tape here, 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 and this area. Okay, so now we can add some water into this leaf like this. The amount of water is not important to be accurate, and burn the downside of leaf on this fire of candle. The time for burn is around 5 minutes. Okay, we continue our experiment with another leaf. We don't have to add water and just burn directly without water. Okay. Can you see that? I think we can stop here because it will no longer in proper condition, so we stop here. You have seen the result, right? We can see a big difference between leaf
with the presence of water and without water. So why is this happen? The heat capacity of water is so high, and when this leaf, we burn this leaf, the fire transfer the energy in form of heat upon this leaf, but with the presence of water, the heat energy was transferred from the surface of the leaf and to the water. So the water is the best absorber of heat, so that the presence of water can prevent the leaf from damage. Okay, thank you. That's all for me.
Assalamualaikum. My name is Nur Hazarina Nazaha binti Hasanuddin, and my matrix number is E201910235884, and I'm from Diploma Science. So for today, I would like to do an experiment for the water density. So let's start. So in this experiment, I'm gonna use 2 glasses which is filled with tap water, common salt, 2 lemon, and then tablespoon. So the procedure of this experiment is very simple, which is we gonna use 2 glasses with fill of tap water, and then the first lemon will be enter into a first glasses. So we can see that the lemon sink in the water. For the second glasses, we will add 2 tablespoons of salt, and then we will stir to make sure the salt dissolve completely with tap water. Now we obtain salt solution which is denser than the common tap water. Then we take another lemon and put it into the glass of salt solution. So we can see that this lemon doesn't sink in the water but float in the surface of the water. This is because the density of this lemon is less dense than the density of water, so it floats in water. On the other hand, the density of the lemon in the common tap water is higher than the density of water. This is reason why one lemon float while the other one sink in the water. Finally, this experiment showed that an object which has less density than water floats in it, while the density of other object which is higher than the water sink in it. So this is my experiment. Hope doctor will enjoy it, and thank you. That's all for me.
Reflection on the importance of unique water properties for organisms. Water is an excellent solvent. It's able to dissolve many polar and ionic substances. And this is important to all living things because as water travels through the water cycle, it takes many valuable nutrients along with it. Furthermore, water has cohesive and adhesive properties, which are essential for fluid transport in many forms of life. For example, they allow nutrients to be transported to the top of a tree against the force of gravity. Next, water has high heat capacity. It takes a lot of energy to raise the temperature of a certain amount of water by a degree. So, water helps with regulating temperature in the environment. Density of water. Water is less dense as a solid than as a liquid. This keeps ponds, lakes, and oceans from freezing solid. and allows life to continue to thrive under the icy surface.